Welcome to the revision classes on system modeling and simulation. So, simulation examples is the next topic here. So, what we are doing is some points are listed. The simulation, this chapter are carried out by three following steps. Uh, One is determine the characteristic of each of the input, okay, to the simulation. So, simulation can be either continuous or it can be discrete. So, most of the cases we are considering here as the discrete simulation only, discrete event simulation only. Then the second one, construct a simulation table, okay, against to the input and its behavior. So, each simulation table is different according to the problem statement, okay. So, one example table that let us see later. Then, point number three, step number three, you can say for each repetition, say the repetition step as I, generate a value for each of the P inputs and evaluate the function, calculating a value of the response. Say response be Y. Okay, it is there in the table as you can see the table here. Input as well as responses. So steps or repetitions, it is marked as 1 to n different steps or n number of times we are going to repeat the same task. Hence it is marked as repetition in the table as you can see. And inputs, various inputs, let the inputs are identified as x, suffix I1, I2, I3 and so on. Okay. And let the response or outcome, right, for the said input, for the said row be indicated as y. So yi, and it varies from problem statement to another problem statement. So queuing system simulation, we'll be discussing once again this as the part of the module number 2. So initially we have to in module number 2 also we have to study about the queuing system only. So the most familiar concept is the queuing theory or queuing system, where we are following a strict rule here in queuing system, that is first come first serve, right? First come first serve. Example, best example is the ticket counter of railway station or a theater, right? Ticket counter, the first one who enters the queue will be served first, will be getting the ticket otherwise first. So we have to consider the arrival, then inter-arrival time, things to be considered. Please recall, right? Arrival of the customer to the queue, that is an event. Then inter-arrival time or a time between the customer, then service time, waiting time. So many things to be considered here, right? Just recall all those things. So two types of events can be defined: arrival and departure event. Uh, as you can see a diagram, this is the flowchart for which shows the departure event. Okay, departure in the sense once the service is completed, the customer should be departed from the queue, right? Departure event, what it indicates. So once the departure event occurs, what happens? Server will be idle, right? Idle time for the server will be started, and that idle time is possible only if there is no other person waiting in the queue, right? If none of the other members are waiting in the queue, server will go to the idle state. Otherwise, what will happen? If somebody are waiting in the queue, server cannot be idle, right? Suppose in a bank counter, yeah, in a bank counter, if there are many customers are waiting for cash withdrawal or cash deposit, you can say, and there is a single teller, say single teller in the sense cashier. What happens is once the particular customer, say customer A, has completed his task, say depositing the money of 10,000 or 20,000 whatever in his account, then he will be departed. Person, if suppose person B is there waiting behind customer who is standing behind person A, then B will it will be turn B's turn, right? B will be the B will be standing at in front of the queue, so he will be getting the service, either withdrawal or deposit, whatever the service he will get, and so on. It will continue till the last customer of the queue. So if there is no more customer in the queue, then he will be in idle state. Who? Cashier will be in idle state. That is what the begin. That is what indicated here. Begin server idle time. When another person is not waiting. Means if another person is waiting, then what you have to do? You have to remove the waiting unit from the queue. So his event till time his state was different, person B state was different, person B is standing behind person A, right? Person A is there in front of the teller or cashier getting the service. Once his service is completed, it will be the turn of person B. So remove the waiting unit from the queue and start serving person B, right? Begin serving the unit. That is what you can see. Very simple things. Easily you can answer for such type of questions. Next is the another type of event, arrival event. So the thing is, these events, no, which changes, which causes the variation of the system. That's it. So arrival event. So what happens for arrival event? If the server is busy, once again there are two possibilities. When a customer arrives, arrival event occurs. If the server is not busy, he will be directly uh, moving to the area, and he will be going directly towards the in front of the counter, and he will be getting the service. Otherwise he should wait in a queue. That's it. Wait for his turn, right? These are the simple flowchart diagrams of the queuing system. A single server queuing system it is. So single server queuing system, diagrammatic representation, as you can uh, mean, go through this diagram also. So waiting line and server, easily you can say. So this is what the waiting line, or say counter. There are 10 customers are allowed. Assume in front of the counter of a bank cash counter, maximum 10 customers are allowed, and rest of the people will be there outside. Assume rest of the people will be there outside. So waiting line, one by one people will be getting the service, and they will go back once the service, their service is completed, and they will go back to the waiting, sorry, calling population, right? And the new customer from calling population will be entering into the waiting line. So tabular representation also you can go through. So these tables which tells you about the actions taken based on the state of the queue. Okay. Server status as well as queue status. Server status as well as queue status are marked. There are two possibilities for server. What are the two possibilities? Either server can be busy or server can be idle. And two status of the queue are queue may be empty or queue may be full. That is not empty or empty. Say. So server status. Now read the statement like server status is busy and queue is not empty. Okay. Then what the person supposed to do, what the customer supposed to do? He will simply enter into the queue. If the queue is empty and server is busy, also you are supposed to enter into the queue only, because server is busy. If server is busy, then you have to wait in a queue. Please remember, if server is idle, then queue is not empty. It is marked as impossible because there is no question of queue, right? You will be the only customer who is entering there, and you will be taken to the service. You will be directly given the necessary service will be given to you. So you cannot have a concept of queuing and all. No need to wait there. don't wait in a queue. You will be the only customer standing right in front of the counter, and you will be getting your service, necessary service, right? um, right. So not empty is not possible, that's why. And if queue is empty, you have to enter into the service. So this state is actually not there.